Hi everyone, welcome to Differential Calculus. Today we study a special section on hyperbolic functions. Number one, hyperbolic cosine. Let's say we have two poles for one, for two, and we want to place a power line cable between them. How would we place the power line cable? We have to be a little careful though, because too much and the line gonna sag due to gravity. Too little and it will break due to tension. So we need to figure a way that we can model the power line cable. And it will take a look at these two functions. Then there's something that we can do. The first function is this one. Y equal half of e to the x. The second function is just y equal to half of e to the negative x. So if we add them up, then there is something in between. And this function is y is equal to half of e to the x plus half of e to the negative x. We call this function the hyperbolic cosine of x. So that is where the hyperbolic cosine come in. It's very useful to figure out how to place the power line cable correctly. Let's take a look at the derivative of hyperbolic cosine. See what we have. Take a look at the derivative of hyperbolic cosine. So this is the same as the derivative of half e to the x plus half e to the negative x. And what we have is half e to the x plus half e to the negative x times negative 1. So we have half of e to the x plus negative 1 over 2 e to the negative x. What is this derivative here? Let's do some sketch. Okay, so we know how to sketch half of e to the x. Negative half of e to the negative x is this function. So what happened is that we have to negate the function, and then we do a reflection over the y-axis. So it will look something like this. Y equal negative 1 over 2 e to the negative x. Okay. And if we add them up, well, what we have is this function the derivative of hyperbolic cosine x. Okay, so there has to be a name for this one. And based on the derivative of cosine, well, derivative of cosine is negative sine. In this case, this function is not negative. So we call it hyperbolic sine. Pretty cool, huh? Now let's take a look at the derivative of hyperbolic sine. You're gonna see something amazing. That would be the derivative of half of e to the x plus minus half e to the negative x, which is half of e to the x plus minus half e to the negative x multiplied to -1 due to the chain rule. And what we have is half e to the x plus half e to the negative x, which is the hyperbolic cosine. Inverse hyperbolic function. Notice that the graph of hyperbolic sine is 1 to 1, so it has an inverse. How do we figure out the inverse of hyperbolic sine x? To do this problem, we just have to let y equal to the inverse hyperbolic sine of x, similar to how we deal with the inverse function in trigonometry. We use the inverse property. So that means hyperbolic sine of y equal x is just an inverse property. Okay. Hyperbolic sine of y is half ey minus half e to the negative y equal x. Now, from there, I can multiply both sides by 2, and we have ey minus e to the negative y equal 2x. So this tells us that ey minus 2x minus e to the negative y equal to 0. The trick here is we're going to multiply both sides by e to the y to get e2y minus 2x ey minus 1 equal to 0. And then from here, if we let e to the y equal t, then what we have is a quadratic equation. T squared minus 2xt minus 1 equal to 0. And from here, using the quadratic equation, we see that t equal minus b, so that's minus 2x plus or minus root of b squared minus 2x square minus 4ac over 2a. And this gives us 2x plus or minus root of 4x squared plus 4. So that would be over 2. So we have 2x plus or minus root 4 root of x squared plus 1 over 2. And then from here, we can factor out the 2 and do the cancellation. So that would give us x plus or minus root x squared plus 1. Okay. Root x squared plus 1 is greater than x. Since p is e to the y is positive, and root of x squared plus 1 is greater than x, p can only be x plus root x squared plus 1. We know t is e to the y equal x plus root x squared plus 1, which means that y is equal to ln x plus root x squared plus 1, and y is exactly the inverse hyperbolic side of x. Wow, pretty amazing. Thank you for watching. I hope you found the content useful. Please subscribe to help the channel grow. I'll see you in the next video.